Hello, and welcome to week 2 of Computer Science 12 Java Programming. Today we're going to talk about variables and expressions. And I've written on my iPad here, I've written all the notes that I would normally write on the chalkboard. So unfortunately they're already here, but I will go through them as if I was writing them on the chalkboard. So if you're taking notes, this is a good thing to write down what I've written down. So we're going to talk about variables, and basically variables are a named location in memory. You should have learned that in CS10. So all values are stored in memory, and in our programs we're able to give those locations a name, so we don't have to worry about the actual memory location, which is an address. So we can give it a name, and then we can assign a value to that variable. We can change the value of the variable. We're talking about code 12 right now, and code 12 is not a complete version of Java. So the variable types that we are going to have in code 12 are int, which is an integer like numbers, 1, 2, 3, double, which is a floating point value, so it would have a decimal point at the end, like 7.5. Boolean, that's a value that evaluates either to true or false. A string, that is a word or anything that we put into double quotes. And a game object, and that is a class variable type that we're going to be using in order to draw shapes and things in code 12. And so when we draw a circle, we can actually create a circle it's a game object. We can assign a variable name to it, and then we can do things to that circle. We can make it move across the screen, we can change the color, we can change the size. We can manipulate the variable. When you're creating variables, you want to give names that are descriptive. So instead of using X, Y, Z, we like to give actual names to our variables. Sometimes you will see me use X, Y, and Z, for an example, but when we're writing programs, we make our variable names make sense. So things like average, area, temp, those are variables that make sense. You can look at the name of the variable and you can assume what value it's going to have. Okay, variables in Java must start with a letter. Okay, and by convention, variable names start with a lowercase letter. And then after that, they can have letters, digits, and the underscore. So those are the only characters that you can have in your variable names. There should be no blanks. So if you want to separate words, you can use the underscore. But another way to do it is by this thing called camel case. Camel case means that we put capital letters in to separate the names in the variables. So here we have circle area, days of week, X pause, Y level. Those are variables that are using camel case. Makes it easy to read what the variable name is. You can make your variable names longer, and they're easy to understand. By convention, we have constants also, that the names of the constants are capitalized. Okay, so if we're going to have a constant, now what a constant is it's a value that you're never going to change. So variable, the reason it's called variable is the value changes. Okay, constants are a variable, but what we're going to do with a constant is assign it a value, and then we're going to use that name all through our code. It's not going to change. If we ever do change it, it's assigned in one place. So you might have a variable called pi that you assign 3.14, and then you can use that variable pi all over your code instead of having to type in 3.14. Okay, we can have this. Here's another one, days in week. This one, it's all capital letters, but we can separate the letters using underscores in this particular case. When you declare a constant, you're going to declare it using this term final. So we're going to talk about declaring variables. You put the type of variable it is, and then you put the name of the variable, and then optionally you can initialize the variable to a value. When you have a constant, you put the word final in front of that declaration. Okay, so here are some examples of declarations of variables. Okay, you can declare an integer variable temp by saying int temp, and notice there's always a semicolon at the end of the line. Every line of code in Java always has a semicolon at the end. We can say double area, Boolean flag, string name. You can also say int a b c. So essentially you can declare 3 variables of the same type all in one declaration. So you don't have to declare them all individually if they're the same type. We can initialize values when we declare them. That would be like here, int temp equals 96. So we can initialize it to 96, then if we change the value, it'll change, but we have an initial value. You might want to initialize something to 0, double area equals 0. Notice I have 0.0 because it is a double, it's a floating point number. Boolean flag equals true. For Booleans, we use the words true and false. And string, and notice that string has a capital S. Okay, when you're declaring a string variable, it has a capital S because actually in Java, strings are a class, and by convention, we're going to name strings starting with a capital letter. So that's why variable names start with a lowercase letter, but class names will start with an uppercase letter. So here I have string name equals Susie. Notice Susie is in double quotes because it is a string. Next we're going to talk about assignment statements. Assignments are when we take a variable on the left and we give it a value on the right of an equal sign. So we use equals for assignment. In different programming languages, they might use a different symbol for assignment. Java uses equals, and that's in most programming languages, but you never know. They might have some other symbol. So here are some examples. Int x equals 10, int y equals 20. Then we can say y equals x plus 5, x equals 100, and then print y. Well, we start out where x is 10, okay, and y is 20. Now we're going to set y to x plus 5. So if we have here, if we have the value of x and the value of y. So x starts as 10, y starts as 20. Okay, y equals x plus 5. So if we take x, which is 10, we add 5, we get 15. So the value of y becomes 15. Okay, it gets overwritten and becomes 15. Then we set x equal to 100. So the value of x becomes 100. And now if we were to print y, we would print 15. So every time you reassign the value in an assignment statement, the variable then becomes that current value. Okay. There are different levels of variables, meaning when we talk about class level variables versus local variables, what that means is when we declare the variable, where can we use the variable? Okay, variables can only be used where they are declared, and you can tell where they are declared by looking at the brackets. Okay, so the brackets enclose that class. Here the brackets enclose a function, a method. Here the brackets enclose another method. So right here we have a variable called size. We're setting it to the value 20. This is a class level variable because it's up here within the class. It's defined right inside the class before we can get into any other brackets. That means it can be used anywhere else in the program. Okay? So now we have the function, the start function, which in code 12, you'll notice there's a start function and an update function. The start is a function that lets us just initialize everything in our code, and the update, the code eventually runs 60 times a second, and so that's where we're going to do things like move circles around on the screen, move objects around on the screen. Okay, so we have here public void start, and in here we're going to declare another variable called pause. Now this variable pause can be used inside the start function, but it is not acceptable in the update function. It is not declared in a place that the update function can use it. Okay, so I can use pause here and I can use size here. So I'm going to draw a circle that's of size 30. Pause is 50, or it's not size 30, sorry. It's at x coordinate 30, y coordinate 50, and the size is 20 because size is declared to have a value of 20. So we can use our variables inside function calls as parameters or arguments. Okay, you'll notice that in the update function, neither size, well, size can be used. Size can be used here because it's declared up as a class level variable. But pause, which was declared locally inside the start function, cannot be used, cannot be accessed inside the update function. Okay, so hopefully that's clear how you where you have to declare your variables. So if you don't need a variable used throughout the entire program, just declare it in the function where you are going to use it. Okay. Expressions. So expressions are where we can basically, you can do math or any other kinds of expressions, and so it's a combination of values and operators in order to calculate values. Okay, so we have the plus sign, which is addition, the minus sign, which is subtraction. We use an asterisk for multiplication. We use a slash for division. A percent sign is called modulus, which gives you the remainder of division. So if you have 5 modulus 2, well, 5 divided by 2 is 2 with a remainder of 1, so the result would be a 1. It's the remainder after division. Okay, plus plus is adding 1 to the value. It's a shortcut way to add 1. Minus minus is a shortcut way to subtract 1, and star star is exponent. This is exponent. Okay, so for example, you can have x equals y plus c. You can have a equals b times c divided by d. You can have any combination of these values. You can also use parentheses. We can say a equals b plus c divided by d. Okay, so parentheses make it, the parentheses are done first. So we have an order of operations, and you should all be familiar with PEMDAS. We all learned that in elementary school. This is parentheses, exponent, multiplication, division, addition, subtraction. So if you don't have things in parentheses and you're not going according to PEMDAS, it goes left to right. Okay, so if we have the expression 3 plus 2 times 5, well, it's going to do the multiplication first, and then it's going to do the addition second. So you're going to have a result of 13 here. Okay, if you want it to be the other way around, you'd have to say 3 plus 2 in parentheses times 5. That would give you 5 times 5, which would give you 25. So you can see that it's two different, very different values that can result from your expression depending on the order of the operations. So be very careful when you're writing your expressions that you take that into consideration. I also like to put spaces in between my operators and the values that are operating. So I would put 3 space plus space 2 space times space 5 semicolon. It makes it much more readable than if you squeeze it all together. Okay, here's some examples of the shortcut notations. X equals x plus 1. You can change that to either, there are some shortcut notations where if you're taking x and adding a value to it, you can use this plus equals. Okay, x equals x plus 8, you can say x plus equals 8. When you're adding 1, you can just say x plus plus. So there's a whole bunch of shortcuts. We have plus equals, we have minus equals, plus plus, minus minus, times equals, divided by equals. And that's only if the variable that you're now assigning is going to change itself. Okay, so it only works if you have the same variable on the right that you're doing something to, and then assigning it back to the same variable on the left, the same name. So know that you can use those shortcut notations, but you don't have to ever use the shortcut notations if you don't want to. Okay. When we're dividing values, it's very important to make sure that at least one side of the expression is of type double. There's this thing called integer division. Okay, so at least one side of the expression needs to be of type double in order for division to work correctly, because often when we divide we end up with something on the, a decimal point value. We end up with a remainder. In Java, if both sides are integers, then what will happen is the result will be truncated. So where here, if I say 175 divided by 10.0, okay, 10.0 makes at least one of the sides a double. This will come out to 17.5. But in Java, if I was to say 175 divided by 10, and they're both integers, then that value will get truncated. Not rounded, truncated. So the 0.5 just disappears, and it becomes 17. So in order to make sure that everyone is doing their division correctly, code 12 is going to give an error if we have integer division. So code 12 is not going to allow integer division. Okay, regular Java does, but again, you have to be very careful with it. Okay, so if you do want integer division, there are times when you might actually want to divide and only have the part on the left side of the decimal point. You can do a few things. Okay, well, in order to make sure that you have doubles, first of all, you can either add a decimal point to at least one value. You can do what's called casting, where you put the word double in parentheses, and that makes this value, makes num into a double. Or if you actually want to use integer division, there is a code 12 function method called indiv, and you can put two values in there and it will give you back an integer, the integer part of the division. Okay. One more thing is string concatenation. So we can take strings and we can use the plus symbol to combine the strings. So now the plus symbol, when you have strings, it's not addition, it's concatenation. Okay, so Java knows that if I take two strings and put a plus in between them, that instead of doing addition, because obviously you can't do addition with that, it's going to take the strings and it's going to concatenate them. So if I say string name equals Susie plus mono, and then I print name, it's going to print Susie mono right here. Notice there are no blank spaces in there because I didn't put any blank spaces in there. So if I want blanks, I need to make sure I put a blank in there. What I can do is I can say here Susie plus blank plus mono, or I can put a blank, either before the mono or after the Susie. So I can concatenate more than one string in an expression if I want to. Okay, so make sure that you do put blanks in if you need them. Here's another example. String first name equals Susie. String last name equals mono. I can say string full name equals first name plus blank plus last name. So now when I go to print, it's going to print Susie mono. Now I could have declared my variables separately, so I can always say string first name. I don't have to initialize them when I declare them. Last name, full name. Okay, and then I can say first name equals Susie. So know that you can declare all your variables in one place and then use them later. You don't have to initialize a variable when you declare it. However, if you're going to have a variable, you must declare it as a type before you can use it. Okay, so that's pretty much everything that I need to teach you this week. Not a whole lot, it's easy. So you're going to have a programming assignment too. Make sure that you set Code 12 syntax to level 4. Okay, very important, that's level 4. It's only going to allow you to do what we've taught so far. The programming assignment is very open-ended. I just want you to experiment with variables and expressions. Make up your own variable names, put variables in different places, write some different expressions. If you want to make it meaningful, you can. There are some suggestions as to some things you can do to make it meaningful. But you don't have to. I just want to see you have enough content in there that shows me that you've done a lot of experimenting with variables and expressions. So have a great week. If you have any questions, please send me an email. And remember, my office hours will be Thursday from 4 to 5. I'll have a Zoom link that you can go to join in, and I'll just be online that whole hour. So until next week, have a good one.